Hello and welcome to 90 East. When you put a container of water on a table, the combined weight of the container itself and the water inside it exert a downward force on the table. If you were to replace that container of water with an identical one of, for example, vegetable oil, the force exerted would be slightly smaller. But why is that? Well, because oil weighs less than water for that same volume. Another way to describe this is to say that oil is less dense than water. Density is simply a way of describing how much mass a substance has for a given volume. We calculate it using the following equation. Density equals mass divided by volume. Interestingly, the density of a substance isn't constant. It changes, and it changes depending on lots of different environmental factors. We can see that here, where 1,000 grams of liquid water at room temperature takes up a volume of approximately 1 litre, or 1,000 cubic centimetres. It has a density of 1 gram per cubic centimetre. If we were to heat the entire mass of this water up to create steam, it would take up a much larger volume. What do you think would happen to its density? Well, let's have a look at the equation here. Density equals mass divided by volume. So the mass is the same because it's the same number of water molecules, but what's changed is the volume. It's increased. Because volume is the denominator in this equation, that is, it's down the bottom here, as it increases, density will do the exact opposite. It will decrease. So the general trend is that as a substance moves from solid to liquid and from liquid to gas, that is, as its temperature increases, its molecules will get further apart from one another, so its volume will increase and the density will decrease. Now, of course, there are exceptions to all the rules, and one of the exceptions in this instance is water. As water is cooled from steam to liquid and from liquid down to approximately 4 degrees Celsius or 39 degrees Fahrenheit, its molecules will get closer to one another as we've described. But at temperatures below that 4 degree mark or 39 degrees Fahrenheit mark, the molecules don't actually get any closer to one another. Why is that? Well, the best way to think about it is like this. Water molecules are like tiny, tiny little magnets. They're not actually magnets, but they kind of act like them with one another. If you have a magnet in each of your hands and you move them around really, really fast, nothing much will happen. But then as you slow them down and you bring them really close to one another, all of a sudden the positive side of one magnet will attract the negative side of the other. You may know already that water molecules are made up of an oxygen atom and 2 hydrogen atoms. Because of the way the electrons are distributed in a water molecule, the oxygen atoms are actually a little negative and the hydrogen atoms are a little positive. In a liquid or gaseous state, the water molecules are moving around relatively fast and relatively far away from one another, so these positive and negative poles of the molecule don't really matter. But as the temperature of the water decreases, they slow down, they move close to one another, and then just like magnets, the opposites attract. So when 2 molecules get really slow and near each other, they line up so that the negative oxygen atom of one molecule is near the positive hydrogen atom of the other. As the temperature of the water decreases further, more and more molecules line up like this, and it creates a crystalline structure. And this crystalline structure has extra space in the middle here that wasn't necessarily there before. And suddenly the water will expand as it freezes. This is actually a really well-known phenomenon, and it's the reason why you should make sure you don't fill water bottles right up to the top before you put them in the freezer, because if you do, the water won't have space to expand into, and the bottle will burst as the water tries to freeze. Now, there are also other factors that affect the density of a substance, like pressure, but they're beyond the scope of what we're looking at in this video. For now, you just need to remember that density is simply a way of describing how much mass a substance has for a given volume. That's calculated by dividing mass by volume, and that as the temperature of a substance decreases, its density will generally increase. In our next video, we're going to be looking at another interesting characteristic about frozen water, so make sure to subscribe to the channel so that you don't miss out. And if you found this video useful or interesting, please like it and let us know in the comments below. Your comments are really, really, really encouraging, and I really, really appreciate them, and I appreciate you. Thanks so much, everyone.